All you really need to know is the order, and that red is the biggest, violet is the smallest, violet has the most energy, red has the least energy. Done. That's really all you need. These are your three equations. You've got the wave equation over here, developed by Schrodinger. You've got the Planck equation, which is how we linked energy to frequency. And this is Einstein's equation, linking energy to mass. Now, first off, all of these equations by themselves are easy because every single one of them has a constant and it has two variables. That is like the easiest algebra you can ask for, a constant and two variables. So your constants, your C's, these are constants. Your H is a constant. These numbers do not change. They don't. The C that you have up there is right here, 3.00 times 10 to the 8th. I mean, you don't need the 0 zeros in your math, but it just lets you know that there's 3 sig digs built into this. So 3 times 10 to the 8th is C. So it's C over here, and it's C over here. You just have to square it. Planck's constant is 6.626 times 10 to the negative 34th power joule seconds, and that is your H. So these three things are constant and they do not change. As such, if one variable changes, then it will help tell you how the other variable changes. So, you know, if you have wavelength, you can use that to get frequency. If you have frequency, you can use that to get energy. If you have energy, you can use that to get mass, and the reverse. So these equations are all pretty darn helpful and easy by themselves. The issue is sometimes you need to use more than one of them. So here is Mr. D's pro tip on which equation do you use. If you have wavelength, you're using the wave equation. If you have mass or moles, you're using Einstein. And then if you're not using either of those, you're using Planck. There you go. That's my crash course into how you can figure out which one of these you should use. All right, sometimes you will need to use more than one of them, as emphasized earlier. Now, the units for wave math should be these four. You should always use joules, meters, seconds, and kilograms. Always using these four means your answer will be one of those four. And it's all based on the idea of what a joule is. A joule links kilogram, meters, and second. This makes joule the second most useful unit in chemistry, the first being the mole. The mole does more than the joule, but the joule is pretty darn useful, and you'll see the joule in physics for those of you who take it. So you always want joule, meter, second, kilogram. And you always get joule, meter, second, kilogram. So here we go. Calculate the energy from a wave if it has that wavelength. So first off, because it is sitting there and saying it has a wavelength right here, this means we are going to use the wave equation. Now, if we are using the wave equation, we know we need that. We are going to get frequency. So when we're talking about energy, this could either be Planck or it could be Einstein. It could be either of those. But because it is telling me that I'm going to be using my wavelength, which was right there. So it's either going to be Planck or Einstein. But wavelength is going to give me frequency, which means that's going to be Planck, not Einstein. So there is no mass, no mole, because remember we can go mass to mole very easily. So we're definitely not going to use Einstein here. We're going to use Planck, especially because we want V. We want our frequency. So here we go. As such, I check my unit. My unit is in meters, which is good. That's one of my ones I can use, so I don't need to track units anymore. I start with my wave equation. C equals wavelength times frequency, except what I want is frequency. So this is going to become, I'm going to alter it. I'm going to divide both sides by wavelength so that frequency is by itself. And this is going to give me the equation I'm really going to use, which is frequency is equal to C over wavelength, like so. So what does this mean? Well, C is always the same thing. C is 3 times 10 to the 8th power. And my wavelength I can get from the problem that's up there. Okay, so wavelength is listed right here. That was very sloppy, but whatever. 9.53 times 10 to the negative 8. I don't need to track units anymore because I know if I start with meters, I'm going to wind up with joules because of what I said earlier. Now, when we're doing math under the line, we need parentheses around that, so there we go. I take my calculator, I do 3 times 10 to the 8th power. I divide it by parenthesis 9.53 times 10 to the negative 8th power, end parenthesis equals. This gives me, my frequency. And my frequency in this case is 3.14795, and there's more. ... It doesn't matter because we are not going to use that much. Times 10 to the 15th. You need to be careful about that. Now, since this is frequency, it's going to be in hertz, which is just per second. So that doesn't matter because we really don't care about units. That then brings us to Planck. Planck is E equals HV. We can use this exactly as it is because we have H and we have V. So I continue. H is Planck's constant, which is 6.626 times 10 to the negative 34th power. And that is going to be times the frequency that we calculated earlier, 3.14795 times 10 to the 15th power. So I take the number that's still in my calculator, hopefully. I times it by 6.626 times 10 caret negative 34 equals. And I get my answer. Okay. My answer in this case is I set it to 3 sigdigs based on the fact that I've got 3 sigdigs here. So I am going to be at 2.09 with rounding times 10 to the negative 18th power, and this will be in joules because it told me that because I had meters, then that means I will wind up with joules, because if we use the right units, we will always get units we can predict. If I start with meter, second, and kilogram, I will get joules. So I'm good. And there you go. That is a crash course in how to do a multi-part light conversion. I actually thought that went pretty darn well and quick. Let's take a quick look at some other ones, and you can see other work that I've got here. One of the things that you need to identify is what equation to use when. So as I look here, the energy of a ray with a frequency. This is talking about energy. And this is talking about frequency, so this is Planck. The next one says frequency of violet, so it's talking about frequency, and it gives me wavelength, so it's definitely the wave equation. And the last one here, mass of a wave with an energy of this. Well, okay, energy and mass, yeah, that's totally Einstein. So your job will be to figure out which to use and then just use them. Now you do have to be careful because one of these is not in the right unit, and that's here. This wave equation is in nanometers. We need to change that to meters so that our math will work smoothly. And you should know how to do that, but if you don't know how to do that, 1 meter is equal to 10 to the 9th nanometers. You use that equality first to change it to meters, and then you do your wave math, and you'll be fine. Okay, now some more complicated ones, and it shows you the answers and tells you stuff. Now, you've got these questions here. 6 and 7 are just concept questions, but 4 and 5 are not. Now, first off, 4 tells you have nanometers, so you're going to do the wave equation again using that. But then it has energy. Well, just like we did with our sample question, we then want to use Planck because wavelength will give us frequency, which will give us our Planck. So basically, we're going to start with wavelength, we're going to get frequency, and we're going to use frequency to get energy. So this is why we do it that way. So this is Einstein, no, sorry, it's not Einstein. It's everything but Einstein. It's wave, and then Planck's. This is a wave-Planck question. I do the wave equation first, the Planck question second. The next one asks for mass. That is definitely Einstein with a frequency. Well, in this case, if we have mass and we've got frequency, so we can take frequency and change that to energy using Planck. So we can take frequency, change it to energy, and then change energy to mass. So in this case, our thing we're going to use as a bridge is energy. We're going to do frequency to energy with Planck, and then we're going to do energy to mass with Einstein. So this sort of mental calculation is what you need to do whenever you see a wave question. And I can guarantee you that I'm going to ask you wave questions that have more than one equation to it, both on the test and possibly on the final, because it is kind of a big skill.